Greetings, eco-nerdlings. In this podcast, we're going to be discussing groundwater and ocean pollution. Chemicals used in agriculture, industry, transportation, and homes can spill and leak into groundwater and make it undrinkable. There are both simple and complex ways to purify groundwater used as a source of drinking water, but protecting it through pollution prevention is the least expensive and the most effective strategy. So groundwater cannot cleanse itself very well. This is the source of most of our drinking water, and we have a lot of pollutants that get stuck in the groundwater supply. We have fertilizers and pesticides, gasoline, organic solvents, and pollutants dispersed in a widening plume right now. So groundwater, again, since it can't cleanse itself very well, this means that there are much slower chemical reactions in groundwater due to a very slow flow. So contaminants can't get diluted like they can in rivers. There's a much less dissolved oxygen, there are very few decomposing bacteria, and it has lower temperatures. So looking at this graphic, here are some of the principal sources of groundwater contamination in the United States. Things that we've talked about over and over in this class. Coal mining, coal strip mining, pesticides and fertilizer runoff from farms, feedlot runoff, gasoline stations, landfills that have some of their chemicals leaching down into the groundwater. We have acid rain, which can actually affect groundwater if it rains down, and then again it can leak into the groundwater eventually. So looking at the groundwater pollution, it's a serious hidden threat in some areas, especially in developing nations such as China and India. In China, 90% of all of the urban aquifers are actually contaminated or overexploited, meaning that they're going to run out very, very soon. In the United States, the FDA actually reports that toxins are found in many of the aquifers that you and I drink from. Some of the threats, again, are gasoline, oil, nitrate ions, as well as arsenic. So how are we going to prevent this? Well, it's the most effective measure. We need to prevent ground contamination because it's so hard to clean it. Number one, it's obviously underground. So the cleanup is going to be very long and it's going to be very costly and expensive, as well as time consuming. So what are some of the solutions for groundwater pollution, and how can we prevent it? And then how can we clean it up if the water is already polluted? So looking at prevention versus cleanup. So ways to prevent groundwater pollution: we can find substitutes for toxic chemicals that we use. We can keep toxic chemicals out of the environment. We can install monitoring wells near landfills as well as underground tanks. We could require leak detectors on underground tanks. And we can ban hazardous waste disposal in landfills and injection wells. We could also store harmful liquids in above ground tanks with leak detection and collection systems. However, if pollution has already occurred into the groundwater, some of the things we can do to clean it up are to pump it all the way up to the surface, then we clean it, and then we return it to the aquifer. Obviously, this is very time consuming and it's also very expensive. Another implement that we could use is injecting microorganisms to clean up contamination. It's less expensive, but it's still going to be costly. We could also pump nanoparticles of inorganic compounds to remove pollutants. This technology is still under development though. So there are many ways to purify drinking water. We could have reservoirs and purification plants. We could actually process sewer water into drinking water. I believe that California is one of the places that actually does this. We can expose clear plastic containers to sunlight or UV rays. People can use LifeStraws, and we can use Pure, which is a chlorine and ion sulfate powder that can basically clean the water or disinfect it. So LifeStraw, that's something that a lot of you probably haven't heard about. It's actually a personal water purification device. And a lot of times that's something that Americans can take to a developing nation and give to the people there that have to deal with very polluted waters, and their government isn't really getting to the polluted water and cleaning it up in a timely manner. So these are individualized purification, water purification devices. So that's what you see right here. So one of the case studies is protecting watersheds instead of building water purification plants. So basically prevention instead of cleanup. So New York City Water, one of the things that they did was they had reservoirs in Catskill Mountains. They basically paid the towns, the farmers, and others in that watershed to restore the forests, the wetlands, as well as the streams. And this helped them to save the cost of building a plant, which was about $6 billion. So we can use laws to help protect drinking water quality. In 1974, the United States developed the Safe Drinking Water Act. It set a maximum contaminant level for any pollutant that could affect human health. Now, of course, there's a lot of debate. Of course, all of the scientists and health gurus out there say we need to enforce the law and actually strengthen the law and basically lower the higher the acceptable levels. And then water polluting companies obviously want to weaken the law and basically allow for higher degrees of pollutants to be in the water. And then again, the scientists want lower levels of pollutants in the water to be the accepted norm. So, another case study is bottled water the answer? So a lot of people have switched to drinking bottled water because of all of the hype, and you hear about water pollution and this and contaminants in the pipes that are leading to your faucets and things like that. So many people have turned over to using bottled water. Well, some bottled water actually comes from tap water that's basically just purified. And one of the things that people don't really know about is that 40% of bottled water is actually contaminated with different types of bacteria. There's also a very high cost in fuel to manufacture all of those plastic bottles, and we also have to recycle the plastic bottles. And unfortunately, not all plastic bottles are recycled. And the United States is actually really bad about not recycling some of the plastic bottles. And this is 240 to 10,000 times the cost of just drinking regular tap water. So there has been a movement that's called Going Back to the Tap movement, meaning people are trying to encourage others to go back to drinking tap water to decrease our use of plastic bottles. But in order for that to happen, we have to have more laws and stricter laws on drinking water, what's acceptable, what's not. So now we're going to switch over to looking at pollution in oceans. So the great majority of ocean pollution originates on land and includes oil and other toxic chemicals, as well as solid waste, which threaten fish and wildlife and disrupt marine ecosystems. And the key to protecting the oceans are to reduce the flow of pollution from land and air and from streams emptying into these waters. So ocean pollution is growing, and it's a much poorly understood problem, very poorly understood. In 2006, the state of the marine environment was as follows. Approximately 80% of marine pollution originated from land, which includes sewage, and coastal areas were the ones that were the most affected. In the deeper ocean waters, we have dilution, we have dispersion, and we have degradation, so they can handle higher doses of the pollutants. One of the other problems is the cruise line pollution, so basically what's being dumped into the water from all of these huge cruise liners, their sewage has to go somewhere, and unfortunately, it goes into the ocean. In the United States coastal waters, we have a lot of contamination from raw sewage. We have sewage and agricultural runoff. Again, you're going to have an increased amount of nitrates and phosphates being put into the ocean. This causes harmful algal blooms, which in turn decrease the oxygen levels, and it will increase fish kills and decrease the biodiversity of that area. We also have a huge mass of plastic in the North Pacific Ocean, and that's becoming a larger and larger problem. We have huge amounts of plastic debris that are floating around. Animals are ingesting them. Some of them are getting caught up in the plastics. They're getting, flippers that are cutting off. A lot of times they'll ingest it and it stays in their system, so they're not getting nutrients, things like that, and it's having a huge negative effect on the ecosystem of the ocean. So looking at residential areas, factories, and farms, these are areas that can contribute pollution to coastal waters. So we have industry, we have cities that can produce heavy metals, toxin, oil from things, sewage, nitrates, phosphates, all of that, urban sprawl. We have construction sites, farms, red tides. We have a healthy zone, We actually have oxygen depleted zone down here. And then again, we have toxic sediments. These are when chemicals and toxic metals contaminate shellfish beds, and they kill spawning fish, and they accumulate in the tissues of the bottom feeders. So one of the case studies, or a science focus, is the oxygen depletion in the northern Gulf of Mexico. So this is something that you and I should be concerned with since we live in the Gulf. There's a severe cultural eutrophication that's occurring, so tons of nitrates and phosphates are getting poured into the Gulf of Mexico. It's creating a huge oxygen depleted zone. We have over-fertilized coastal areas. We need preventative measures that are going to help prevent more of this from happening. And one of the questions is that not so much will, but when is it going to reach the tipping point? So looking at ocean pollution from crude oil. So crude and refined petroleum has highly disruptive pollutants that can affect all of the different types of life forms in the ocean. It's the largest source of oil pollution and urban and industrial runoff from land. So there are two large oil spills we're going to talk about. First one is the 1989 Exxon Valdez, was when an oil tanker basically crashed. It released a ton of oil, I want to say, into the Alaskan waters. And then in 2010, we had a BP explosion in the Gulf of Mexico. So we also have volatile organic hydrocarbons, and these can kill many aquatic organisms. There's also tar-like globs on the ocean surface, and these can coat animals' scales, fur, feathers, and prevent them from carrying out their normal daily functions like keeping themselves warm. And we also have heavy oil components that can sink and affect the bottom dwellers. So we have a faster recovery from crude oil spills versus refined oil spills. We have cleanup procedures that have been in place, and we also have methods for preventing oil spills. So I wanted to briefly discuss some of the dangers of oil pollution for the marine animals that can get on. So right here, 1 metric ton of oil pollutes an area of 12 square kilometers. So what happens when there's direct contact with the coat of the animal, meaning it gets directly on their fur, feathers, or scales? Well, the oil affects the protective outer coat of birds, fish, and mammals, or feathers, scales, and fur, and it breaks down the insulating capacity of feathers and fur and hinders the movement of other functions. So basically, a lot of those animals have a layer of air, and when the oil goes on, it prevents that layer of air from existing, so the animal will actually die of hypothermia. We have a breakdown of gas exchange, so the film that actually coats the ocean prevents oxygen in the water from being exchanged, so the oxygen levels in the area go down. And then, of course, poisoning occurs. So what's the first thing an animal does if it gets something, on its body? It's going to try and remove it, most of the time by licking it off. So the animals are going to start ingesting that, and it's going to poison them. So two things can happen. One, it can result in their death right away, or two, it can start to bioaccumulate, and basically it goes up the food chain or up the food web, and eventually a higher level carnivore will eat it, and they can see the effects or feel the effects of that poisoning. So what are some of these solutions that we come up with? Well, we have prevention, and then we have cleanup for when a contamination of coastal waters occurs. So some of the things we can do to prevent it are to reduce the input of toxic pollutants. We can separate sewage and storm water lines. We can ban dumping of waste and sewage by ships in coastal waters. We can ban dumping of hazardous materials. And we can strictly regulate coastal development, oil drilling, as well as oil shipping. And we can require double hulls for all oil tankers. So what happens if there is an oil spill? Well, we do have to clean it up. So we need to improve oil spill cleanup capabilities. We can use nanoparticles on sewage and oil spills to dissolve the oil or sewage. This is still under development. We can require secondary treatment of coastal sewage, and we can use wetlands, solar aquatic, or other methods to actually treat the sewage. So looking at this is the picture of the blowout in the Gulf of Mexico for the BP oil spill. This occurred on April 20th in 2010. And then the other one we looked at was the Exxon Valdez oil spill, and this happened in 1989 in Alaska's Prince William Sound. 41 million liters of crude oil were released into the ocean, and it covered 5,200 kilometers of coastline, killing 250,000 seabirds and racking up $15 billion in damages to the economy. And unfortunately, the Exxon only paid $3.8 billion in damages and cleanup costs, and it left the economy of Prince William Sound with the bulk of the cost of cleanup as well as the economy damages that occurred. This spill did, however, lead to many improvements in oil tanker safety and cleanup strategies. Well, I hope you learned a little bit about ocean pollution as well as groundwater pollution. If you'd like to rewatch this video or any others for AP Environmental Science, you can check out my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing off for now. Stay nerdy till next time.